All right, this video is going to go over equations and tables, linear equations, if we're specific. So, if you watch the other videos, linear means it's in the form of y equals mx plus b or y equals kx. So, if you look at the first one, we have a y equals 2x, which is in the form of y equals kx. And we've talked about it in class, and in the last video we talked about that if it's in that form of y equals kx, then it is going to be proportional. Proportional. I'm going to abbreviate proportional. All right. So we're going to first work in filling in the table. So I first want to look at my slope here. What is going to be my slope? Y equals kx. My slope is going to be 2. You want to put it in fraction form and put it 2 over 1. That's also okay. All right, so to fill in this table, I've already given you some x's. So what we're going to do is we're going to plug that x into my equation. You're welcome to use a calculator for this. So I have y equals 2x. But that first x is the negative 2. So I'm going to erase my x, and I'm going to replace it with a negative 2. 2 times negative 2 is negative 4. So my first y value is negative 4. I'm going to do the same thing with each of my x variable, with each of my x's. I'm going to plug it in. It's called the input because I'm putting it in. 2 times negative 1 is negative 2. Erase my negative 1, plug in my 0. 2 times 0 is 0. Plug in my 1. 2 times 1 is 2. Plug in my x again. 2 times 2 is 4. So this table, all I had to do was plug in that x value and solve it. And yes, of course, you may use a calculator, especially if you want to double check your integer work. All right, let's look at another example. All right, our second example is in the form is negative 2x minus 4. So it's in the form of y equals mx plus b. So that tells me that this one is non-proportional. Another word that we use for proportional is direct variation. So proportional and direct variation are the same. So if you see that vocabulary, know that those are they mean the same thing. Non-proportional means it's going to have that plus or that minus after it. All right, so let's look at our table. So I have my equation is y equals negative 2x plus 4. Minus 4, sorry. So my slope here, I'm just going to put an S, is negative 2. Don't forget the negative 2. While my y-intercept equals minus 4. Because remember, sorry, I did not mean to move the screen. It's not going to let me write, there we go. Remember that y equals mx plus b, that m is my slope and that b is my y-intercept. Now, if you remember on the last one, when I had 0 as an x, my y equaled 0. And the reason that is because that y-intercept for the first problem was 0. There was nothing there. There was nothing in that plus or minus spot. So across from my 0, which when I graph it would be where it crosses the y-axis, would also be 0. This time it's not going to be 0 because I have a plus or minus after my equation. So I'm going to take this equation, so I'm going to write it kind of big so it's easy to plug in that x. I'm just going to put the parentheses for the x, minus 4. Sorry about that. So I'm going to plug in my first x. I'm going to replace this x with negative 2. Negative 2 times negative 2 is a positive 4. 4 minus 4 is 0. Replace. My next one's a negative 1. Negative 2 times negative 1 is 2. 2 minus 4 is negative 2. Plug in my 0. Negative 2 times 0 is 0. Minus 4 is negative 4. Notice whatever's across from my 0 is my y-intercept. All right. Place with a 1. Negative 2 times 1 is negative 2. Minus 4 is negative 6. Some of you are saying, well, I see a beautiful pattern here. We're going to talk about that in just a minute. Plug in my 2. Negative 2 times 2 is negative 4. Minus 4 is negative 8. All right, so in a linear table, if my x's are going by the same thing, so if I look at my x's, they're going plus 1, plus 1, plus 1, plus 1, then my y's are going to go by a constant also. And in this case, it's minus 2, minus 2, minus 2, minus 2, minus 2. We're going to look more at that when we write the equation. Notice also for my x values, I have chosen negative 2, negative 1, 0, 1, 2. But it's important to know that this table extends to negative 3, negative 4, negative 5, and on. And it goes the other direction of 1, 2, 3, 4, 5, 6, 7. When I look at a table, I'm looking at just a glimpse of that table, just a piece of it. And I'm choosing to look at the piece that's around the 0. I'm also choosing to look at them going by increments or by steps of 1. So I'm only going by 1 in my x's right now. And I'm just choosing to do that because I like to want to keep it around the center and keep it constant for those of you doing this on your own at home. All right, let's look at our next example. All right, so we have negative x plus 2. So we're in that form of y equals mx plus 2. Now you may say there's not an m there. There's just a negative x. And you're right. But remember, I can say x or I can say 1x. So that negative x is actually negative 1x. An example I used in class is I could say pen or I can say I have 1 pen. It means the same thing. I have an x or I have 1x. So my slope here, first of all, this is non-proportional. Sorry, writing on a screen is a little bit more challenging than you would think. My slope, which I'm going to label it m this time since it is that variable, is going to be negative 1. Notice I didn't attach the x to it. The slope is not negative 1x. The slope is negative 1. It's that coefficient. It's that number before that variable. My y-intercept, which I'm going to label b, is going to be 2. Now, if you've been paying attention, then you know across from that 0 is going to be that y-intercept. So I can go ahead and plug in that 2 if I want to. Sorry, there we go. Woo, that's a hot mess, but oh well. So our y-intercept is always across from our 0. So that just helps me not have to work 5 problems. I only have to work 4 now. So my equation is y equals negative, and I'm going to just put a blank there for the x, plus 2. So I'm going to plug in my x. So negative, negative 2. So I'm going to go ahead and put that 1 there, because remember we talked about that. So negative 1 times negative 2 is 2. 2 plus 2 is 4. I'm going to erase. Clean that up a little bit. So I had negative 1 times my x. My x this time is negative 1. Negative 1 times negative 1 is 1. 1 plus 2 is 3. My pattern so far is 4, 3, 2. You may go ahead and guess the next one, but I'm going to go ahead and plug it in. Negative 1 times 1 is negative 1 plus 2 is 1. Ooh. All right, now I'm going to plug in my 0. Negative 1 times 0 is 0 plus 2 is 2. Uh-oh. Ooh, I'm so sorry. Instead of starting this video over, I'm just going to correct my mistake. Sorry, 2. I went the other direction for some reason. My x here was a 2. Sorry for my mistake. So I plugged in my x there. Negative 1 times 2 is negative 2. Plus 2 is 0. Sorry, I knew the answer ahead of time and I plugged it in. All right. So that's how we'd go from an equation to filling out a table.